Hi students, our study today in this video about profit, revenue, cost. We all know from before that profit is revenue minus cost. So let us take some examples. Example 1, let P of x profit equal 2x squared minus 4x minus 3, where x is in hundreds of units and P of x in millions of Lebanese lira. X is between 0 and 5, and since x is the product, we all know that between 0 and 5 it means between 0 product till 500 product. Suppose each item is sold at 25,000 Lebanese lira. When we say 25,000 Lebanese lira is sold, this is for the revenue. Find the profit from selling 400 units. 400 units, since x is in 100, so directly we must divide it by 100. So we do P of 4. And since the profit revenue cost, the units is in millions, so we must multiply it by millions. So million P of 4, which is 13 million Lebanese lira. Find the revenue function in part B. Revenue is always price that we have, which is 25,000, times X, number of articles, which is unknown. Don't forget to multiply X by its unit over the unit of the revenue. Why? Because if you do cross multiply, here you must multiply by million. Since I want the revenue alone, so we take it to the other side by division. So always don't forget, when you want to use the revenue, you put the price times X, unit of X over unit of the revenue. So this is 2.5X. Now, after they want the revenue for 350 units. So since the profit revenue cost, their unit is in million, so you do million R of 3.5. So you replace X here by 3.5, and by million you have this answer. In part C, find the cost function. We know that the cost here is the revenue minus profit. So this is the revenue, this is the profit. If you do the minus, you're going to get this expression. Find the cost for selling 200 units. This is the cost function. So million C of 2, and you're going to get 8 million. Find the number of items for which the cost is maximum. So we have the cost function that we have found here. So to find the maximum, you do the derivative equal to 0 in addition to the end points. The highest value will be the value of the cost. So for that reason, when you want to do the derivative of the cost, so we do its derivative. The derivative is minus 4x plus 6.5, and if you equate it to 0, so x will be 100, 1.6 to 25, and don't forget that we said round it to 10 power minus 2. If I don't round it to 10 power minus 2, so we're going to get 163 units, and its value million C of you replace the 1.6235 here, or 1.63. So you're going to get 18 millions. Don't forget the boundaries. We have the boundary here, as you can see, from 0 till 5. So you do C of 0 and C of 5. C of 0, as you can see here, it will give you 3, and C of 5, it will give you negative. The cost cannot be negative. The cost always must be positive. So the highest one is the 18.84375 million. And then we want to evaluate the cost for each item. This cost, the 18.84375 million, is for 163 units. To find the cost of each item, directly you divide it by 163, you're going to get 115,686 Lebanese lira. In part F, find the interval of items for which we have gain or gain here they want. We can talk about loss or break even. I have the profit function. This is the profit function. To have gain when the profit is bigger than 0, loss when the profit less than 0, and break even when profit equal to 0. So I want gain. So you take this one, you find the roots in equation of second degree. A is 2, B minus 4, C minus 3. You're going to get 2.58 and a number which is negative, so which is impossible. Don't forget that the interval is from 0 till 5. You cannot take a number outside this interval. So I have this only one. This is P of x. If you take a number between 0 and 2.58, you can take 1. If you replace it here, 2 minus 7, so it's negative. A number bigger than 2.58, you can take a 3. 18 minus 12 minus 3, so 1 positive. So here we have loss, here we have gain. So 2.58 times 100, because x is in 100, 258 units at the break even. So 259 close till 500 at the profit, the number of articles for which we have the profit, and from 0 till 257 the number of articles for which we have loss. So I want to find the profit interval, so I want to do million P of 2.59 and million of P of 5. If you replace it here, we have the profit interval. Number 2, in number 2 we have, this is f of x, x from 0 close. When it's 0, we don't do limit close. If open, we must have limit. Find the limits at the boundaries, so we do limit as x tends to infinity, 2x squared over x, 2x, which is infinity. Prove the existence of an oblique. You do the division. We did it before in the previous video. You do the ordinary division. You do limit as x tends to infinity of f of x minus oblique asymptote. So it remains 20 over x plus 2, a number over infinity is 0. Show that this is derivative. You know, u over v, u prime v minus v prime u over v squared. You can check it by yourself. So when we do the derivative, you equate this to 0. You have 1 of the root 1.1, you go to calculator, you put a is 2, b is 8, c minus 16. You have two roots, 1.162 and another one negative value, but because from 0 till infinity I will put only this one. This is f prime of x. You go to f prime, you take a number between 0 and 1.162, you can take 1. So you can see 10 minus 16 is negative. Here if you take bigger 2, it will be positive, decreasing, increasing. As I said, I don't do limit as x tends to 0 because it's a close. F of 0 is 4 over 2, which is 2. You replace 1.162 here, you're going to get this value, and here we have oblique asymptote. So let me write the oblique asymptote. So here you have y equal 2x minus 8 oblique asymptote. Now first step, we put the point. At one point, this is the point of minimum. Here you can take 2 points. You can take x is 0 minus 8, or you can take, for example, 4, 0. And if you take a 0.5, 10 minus 8 is 2. This is 4 because this is 5. 5 is 2. Here the point, 0, 4. You graph the line, and you have this 4. It comes from the point 0 to go to a minimum, and then you have an oblique asymptote. You can see it here. Show that the intersection of the asymptote is a center of symmetry. Here you have two asymptotes. You have x equal minus 2 vertical, and you have y equal 2x minus 8. We did this before. So if you replace x by minus 2, what do you get? Minus 12. So the formula say that f of 2a minus x plus f of x equal to b. A is minus 2. So 2a, it will be f of minus 4 minus x plus f of x must be equal to b, which is minus 24. So we go here, we replace x by minus 4 minus x here, parenthesis, as you can see, minus 8 plus 20 over minus 4 minus x plus 2 plus f of x. This is f. Directly these cancel out. We did this before, I told you, don't forget. No? These cancel out. It remains, if you do minus 2x plus 2x can be cancel out. So minus 8 minus 8 minus 8 minus 24, which is the case. Area you don't have responsible for next year because it's eliminated due to coronavirus and the online course. But I will talk about it because this video I need it for the year after. Find the area bounded between y equal f of x and two lines of equation x1 and x4. So we do integral from 1 till 4 f of x. You solve this integral as we did before, so you have the answer. But you're not responsible for next year. Now a factory produces electrical equipment. The total cost is in 1,000, don't forget, and x is in 100. The same one here, you have it here. X from 0 till 8, round to 10 power minus 2, don't forget x. Each product is sold at $40. Find the cost of producing 500. So because the cost is in 1,000, so 1,000 C of 5, because I want it divided by 100. You have this value, you replace it here. For what value the cost is minimum. Now we already have the graph of this one. No need to do derivative and the boundaries. You can go to the variation. Minimum, this is the minimum. You can see it here. The minimum is at x equal 1.162 times, they said rounded to 10 power minus 2. So times 100, so it will be 116, and its value is 600, and it's in thousands, so it will be $649. Okay, show that the profit, we need to find the revenue first. Revenue is, we all know the price, which is 40 times x is in 1000 sorry, x is in 100 over 1000, so you're going to get 4x, so profit will be revenue 4x minus the cost. So if you do 4x minus the cost, you can check it by yourself, you're going to get the profit. So what I was saying, 4x profit is revenue minus cost, the cost is 2x squared minus 4x plus 4 over x plus 2, so same denominator if you do it. So you can see 4x squared minus 2x squared, 2x squared, 8x plus 4x, 12x minus 4 over x plus 2. Find the profit from selling 100 units. I have the profit. So x profit is in 1000, so 1000 P of 1 because x is in 100, you divide here by 100. Study the variation. Variation means derivative of the profit, u over v. You can check it by yourself. So now I want to do the variation. You must do delta. You're going to have no roots because delta is negative. When delta is negative, either all is positive or all is negative. So A is positive, so all is positive. So it's always increasing. And when you want to do the variation here, you do x p prime x px. I don't have roots. Because I don't have roots, I have it from 0 till 8. So if you want, because either always plus or always minus, take any number here. 1 for example, it must be always positive, so it's always increasing. So here this is the minimum, this is the maximum value. Find the maximum profit that you may reach akide because it's maximum. We don't have derivative equal to 0. Either at 0, you're going to get at this point, if you do p of 0, you're going to have 28 over 4, or p of 8, the biggest one, so 1000 p of 8, which is the highest, because the function is going up. So from 0, x0 till x is 8, so the highest is at the point 8. So this was the video about profit, revenue, cost. The other video, it will be about the average cost function, but before we do the other video, you're going to have an assignment that I'm going to assign to you. Thank you for listening.